Hello everyone, welcome back. In today's class, we are going to discuss about Unit 2 continuation, that is best first search algorithm. This is one kind of a heuristic search algorithm. Here, if you take any node, there are several steps involved. Okay, step by step we will be explaining here. So in step 1, start by adding the start node S to the open list with the path distances as 0.
So it will be open and closed. So create an open list and a closed list. In an open list, you have a start node and h of n heuristic function, and a closed list, you'll have a node that is visited node and also a parent node of the visited node. So like this, the steps should be repeated till open list is empty or the goal node is moved to the closed list. So when you take a steps to move the first node in the open list to the closed list and expand its immediate successors by adding them to the open list. So there are nodes A, and you just close this node to the move to this node S to the closed list, and its successors are A, B, C. Open them in the open list, and its corresponding heuristic function have been listed here. Then now we are going to expand. It is best for search, right? So you just assign A, B, C, order them with respect to its lowest cost. So order ABC in terms of ascending order of its cost. That is heuristic function. So it becomes a BCA. Now we have to start expanding a B node. So B will be moved to the closed list. Now B's successors are A and D and H. Here if you see already there are nodes that are not expanded. Those nodes also should be retained here. So the expanded nodes also will be listed here with all its heuristic function. Again, you just order them in the ascending. Similarly, now what we have to do, we have to start expanding the C node, and by moving the C node to the closed list. Similarly, we have to continue doing it until we are reaching the goal state. Finally, once the closed list will become empty and reach the goal state, and the corresponding the path where it has been traveled, that should be the path and optimal path of your best first search algorithm from the starting node to ending node E. This is how we have traversed S, B, H, G, and E. This is how best first search algorithm will be working. Now, if you see the visual quick look at searching techniques, we will have, already we know that in searching techniques, we have two major types, blind and heuristic. And blind, we have two types, and heuristic, we have four types of algorithms. And based for such algorithm, it uses an evaluation function for each node, and f of n provides an estimated cost for the total cost. Expand node n with the smallest f of n. How it will be implemented is order the nodes in a fringe increasing order of cost. There is an ascending order. Special cases, there are two special cases, greedy based first search and A star search. And if you consider the greedy best for search and A star search, they have taken the cities of Romania and to travel from one place to another place with respect to its pathcast. And suppose we want to travel from Arad to Izil, and what are the ways we can move? Like, what are the ways we can travel, and which path will be giving the lowest cost? That we have to find out by using this greedy first search or a stall algorithm. So greedy best first search, if you consider it is having an f of function, the function called f of n, which is nothing but estimate of cost from n to goal. F of n is straight line distance from n to Bucharest. Greedy best first search expands a node that appears to be closest to the goal. So Arad is the starting node, and Arad will be expanded with its Arad children. From Arad, so we can able to travel from Cebu, Timsania, and Siand. With respect to its cost also has been displayed. Similarly, we have to expand the next branch. Similarly, we have to expand the every fringe of the parent, and the children are being explored after until reaching the goal state. So if you see here, this greedy best first search algorithm, the disadvantage is it's not complete because it may stuck in the loop. For example, if there are three nodes very close to each other, A, B, C, and there is a node is far node is a D, then what will happen? Your goal state is G means always when you start traversing, you start searching from a state, it will move to B, it will move to C, again it will come back to A as per a greedy best first search because D node is farthest node and shortest node is A. Similarly, it will it will loop around A, B, C itself. It never go to D, and so that it never reaches the goal state as it's stuck in the loop. This is the disadvantages of greedy best first search algorithm. And properties of a greedy best first search algorithm, if you see, these are the parameter analysis, completeness, it never complete as we have seen in the last slide, can get stuck in loops, and the time complexity is O of B power M. But a good heuristic can give a dramatic improvement. And space complexity is also order of B to the power M, keeps all nodes in memory. Is it optimal? No, because already it's not even completing, then it cannot be optimal also. Next, we will discuss about the A-star searching algorithm. A-star searching algorithm is one of the best heuristic searching algorithms we have got. It avoids expanding paths that are already been expensive. It works based on the evaluation functions f of n. F of n here is not equal to f of n. It is also not equal to h of n. It is equivalent to g of n plus h of n. So best for search function will be evaluation function is only h of n, but here, because of that, it stuck in the loop. It has got a disadvantage. So we are going for the more efficient algorithm that is called A-star algorithm. Here, evaluation function of A-star algorithm is G of n plus H of n. Not only we are evaluating H of n, also we are calculating the G of n, where G of n is the cost so far to reach n. H of n is the estimated cost from n to goal. F of n is estimated total cost of path through n to goal. And yeah, if you see the evaluation function for best first search, it is equal to h of n. Uniform cost search also, if all cost searches, f of n is equal to g of n. Whereas this A star is combination of both uniform cost search, best first search, so it works better. So it's a widely known algorithm. It evaluates nodes by combining g of n, cost to reach the node, and h of n, cost to get to the goal. So f of n will be evaluated by g of n plus h of n. F of n is the estimated cost of the cheapest solution. It's complete and optimal since evaluate all paths. So if you consider an example of this particular tree, here the goal state is G and this is G dash. Both are goal states. And path cost is SDG. Actually, they found the path cost. SDG is the shortest and SAG dash is the path for reaching the goal state G dash. So how it has been reached is by finding f of s function for each and every node along the goal state. So initially f of s is equal to g of s plus h of s, and g of s value will be 0, h of s is a 10 initially. So the value will be 10, and f of d similarly if you calculate it is 12. F of g if you calculate similarly it is going to be 0. The h of n value is h of g value is 0, and it's a g value is 3 plus 3. That is the total cost from the source node to g. It is overall cost from the source node. What is the cost? You have to calculate for calculating the g of n. Similarly, if you calculate a f of g and its value is 6, total path cost would be 28. Similarly, we can able to do the path cost for SDG by using f of s is equal to g of n, g of s plus h of s. Now you apply this algorithm, ASR algorithm for moving from Arad to Shibu. It will never stuck into the loop because it will evaluate the total cost f of n plus that is f of n as g of n plus h of n, so that the overall cost, final cost will be calculated with respect to g of n and h of n, so that they never stuck into the loop. If you consider details about A-star search, it is an informed search algorithm as it uses information about pathcast and also uses heuristic to find the solution. To find the shortest path between nodes or graphs, A-star algorithm is a searching algorithm that searches for the shortest path between the initial and the final state. It is an advanced best first search algorithm that searches for shorter paths first rather than the longer paths. A-star is optimal as well as complete algorithm. If we see A-star algorithm, already we discussed that it calculates the cost f of n based on g of n plus g of n, h of n. So the same thing, whatever we've explained so far, again they have been explained in detail. So this is another example for A-star algorithm. You can create the node list similarly like how we have done for greedy base first search. You can create a node list with respect to open and closed. And the open list will be listed here, and the closed list will be listed here. And the closed list will be having h of n and g of n values. So while calculating the nodes to be expanded, you have to calculate its corresponding h of n and g of n values. Based on the h of n and g of n values, arrange them in an increasing order of cost. Based on that, the nodes will be expanded. So already we discussed about a best first search. Another example has been given. For this example, how they are finding the goal state E from the source node S. So we are having two lists. One is a open list and another one is closed list. Under open list, what are the nodes we are going to open it, and corresponding h of n we need to have. Similarly, closed list, what are the nodes that have been closed, and the corresponding parent nodes also should be listed here. So if you take the source list, you will be having the source node and its corresponding cost will be 10. And then the S will be moved to the closed list. After expanding its children, the children are A, B, C, and write their corresponding cost and arrange them in an ascending order. Again, start expanding. If you see the increasing order, B will come first. Then we have to start exploring or expanding B nodes. Similarly, we have to reach until E. So after reaching E, we could able to find where the E is being traversed. Okay, E is traversed from G, H, B, and S. So the corresponding path to reach from S to E is S, B, H, G, and E. This will be the optimal cost, optimum path. So for SR algorithm also we have already explained. This is another example has been given here. So with this, Unit 2 has been end. So thank you all for watching it. Have a nice day.